So we've been talking about test phases. Let's define them a little bit more formally now that we have put them in context here. So at a 10,000 foot view, I like this picture, whole neighborhood there. We can see all these little phases lined up next to each other. Unit testing, integration testing, functional testing, performance testing, all this sort of stuff. Why do we have these phases? And when do they fall into that bigger test plan that goes on? Now, the phases isn't like requirements design test. That's not the idea behind it. We don't have some sort of linear approach to all this that we're trying to get at. The phases is more so the type of focus we're putting on testing. Unit testing is about getting out those low-level bugs in small pieces of hopefully less complex code. Integration is putting those pieces together. Functional testing is checking the requirements. Performance testing is making sure that if it does the right thing, it does the right thing with the characteristics I want to do. Is it fast? Is it, it's used the appropriate amount of data and runtime environment and all this sort of stuff. That's the idea behind this. We'll get into that more in detail. Again, these aren't necessarily lockstep linear things. They can happen iteratively. You can spiral between them. There's all sorts of ways to deploy them, but we need to know what they are individually as well. So the first important thing is when we're talking testing, we are not talking about anything that gets done to build the application. Because I have a developer out there writing code and running tests, it does not mean I'm formally doing unit testing. If the developer is changing code and throwing it on the server, I am absolutely not doing anything related to testing. If I'm debugging something in a testing environment, just because I get it fixed to get that test passed, it doesn't count as formal testing unless there's a controlled process by which I've released that software and can revalidate it all as one. I just want to establish the difference between hacking something together and making it work, like you would at your normal local auto mechanic, versus the process of engineering, which is knowing that there's a repeatable way that this thing will work time and time again. And so when we talk about things like unit testing, the idea is not just I have each class and I test each class to make sure each method in each class does its thing. I know we talk about things like JUnit, and that's the approach it takes with that. But we're talking about formal testing. Unit testing the unit could be an entire web application. It could be a whole series of web services. So a unit could be, okay, you are responsible for testing the administration application. So that way we know the administration application works when we want to go test the public website. So you are in charge of testing all these web services. There's 1,000 of them with 1 million lines of code inside of there. But we need those web services to know that they work before we integrate them with all of the mobile phone apps that you call and use those web services. Okay, so that's the idea. Unit testing has its own component, its own defined functionality, its own interface, and I want to test that thing independently. And that could be, as we said, black box testing. It could be a high-level test of those requirements and the interfaces to make sure it works. Most often it gets into some white box aspects as well. So when I try and create and cover unit tests, each component has its own interface, and I'm going to test that interface. I'm going to test the functionality that's associated with that interface. Again, if it's web services, maybe there's calls to be selling new items or shipping new items or looking up shipping costs or zip codes or whatever like that. All those services should be done independently, unconnected from other aspects of the system, the thing working on its own, because I want to know that that component is working well without bugs that could come up because of its integration with some unrelated piece. It's tough to exactly specify out what that means. It's not, there's not some simple formula on what the bounds of a component are, but ideally it should not be dependent on user actions. That's the most important thing. It should be a piece of its own. So formalizing unit testing is not the most important thing. Some projects do, some projects don't. It becomes formal basically when you start documenting it, or even better, automating it. But formalizing unit testing is a very labor-intensive process. It's not the largest part of the system. And I'll tell you a story later on about in some of the most rigorous software I've ever worked on, we didn't do any unit testing. Unit testing has its advantages. It's really a hardware methodology that occasionally has value in software, but isn't the same thing. It's important to know before I go and build an airplane that the engines work. I don't want to take that big heavy engine and install it in an airplane, then figure out the thing doesn't work and have to pull it all back out again. Software, no matter how big it is, it's light. It's doesn't weigh anything. I just import something and I'm ready to go. And if it's bad, I delete the line and I move on. And so it's not the same level of burden that I have to worry about when I'm working on the integration there. So it doesn't always have to be done super formally like that. Typically, unit test gets executed by developers. They can be formal if they've documented or automated their approaches, and people are reviewing those things. It can be done by a third party, though it's not typical. So I'm not going to really talk much about that too much. The next phase of testing comes into integration testing, which is when I have those components and I start munching them together to make a bigger system. Integration testing, the main point is to see if I can bridge the gaps between systems and make them happen. I've seen integration testing that is 0 time at all. I take plug, I put it in wall, and my integration is successful because there's voltage that goes between them. I've seen integration testing that took more time than developing the system because getting the two systems to talk together was really hard. I once had a project we spent 4 weeks trying to get very simple things to get to talk to each other because we were trying to do some web services, and it was actually a Microsoft web service platform, and there was a security feature that was undocumented and little known that was blocking a whole lot of stuff. I don't get into all the details there. I don't remember all the details there, but I do remember that in order to solve it, I had to look at the ones and zeros going across the line and establish, bitwise at the message level what was being sent back and forth, and in order to be able to see the error message that was coming up, because it looked like it all did work until you turned security on, then it was broken. So integration tests typically are done as part of some other unit. There's seldom is there a formal phase for integration testing. If it is, it's normally considered to be part of a development cycle. But there can be a formal integration step, particularly if there's vendor software involved. If you have two teams that do not work in the same company, you typically will have some sort of integration test phase to make sure everything goes back and forth. And that's where you trade the blame of, oh, I expected to do this and your system's doing that. And they're like, oh, well, that's not what the requirement says. Or, oh, yeah, you're right. That's a bug on our side. So that's typically where it comes in. As I said, it's mostly rolled in some other aspect of testing on most projects. The main phase that we typically talk about when we talk about testing is functional testing. Functional testing being where we look at the components of the system, we've put them together, and we're looking at the requirements for those components to say, does it do what the requirements means? So it could mean flipping through web pages. It could be swiping left and right in your dating application on your phone. It could mean calling web services. It could be looking at files they can produce from batch jobs. Anything that the software does, and whatever that interface level does, is typically what I'm going to be looking at. So functional testing wants to cover all the requirements that are out there. That's where requirements traceability is going to be a thing. And that's why we're going to spend some time on requirements traceability a few times in this class. When I have my tests, I want to point to all the requirements that I'm covering. And at some point, I want to have some accountability that every requirement that's been written down has been tested at least in one place, and then check, does all the places it was tested cover every aspect of that requirement? Excuse me. So we have to consider not just the functionality, but security support, administration, error handling, all the different aspects of non-functional requirements as well as functional requirements when we're doing functional testing. So in my formal testing for my functional testing, sometimes I do it independently. Most of the time I do it independently. I did work at one company where, as the developer, I wrote all the tests, I wrote all the test cases, and I gave them to a test engineer who executed them. because their theory was that they could hire test engineers who could focus on understanding the system and the environment, the hardware, where the software engineers, we knew best what we were writing, but they wanted a separation of who wrote it from who executed it. That's not traditionally the way things are defined. Normally, I want other people to write test cases, not because I don't trust my software developers, but because I want another set of eyes on it. I want another set of perspectives, another set of thoughts on how this thing is supposed to work and how to define how it works. And the most important thing about this, I want to track. What have I tested? How much of my system have I tested? Have I covered all my requirements? Have I run all my test cases? So I can evaluate how many defects are in my system and how many have I gotten out of the system, and how many do I guess are still in the system. So along the lines of functional tests, I want to throw in the phase of regression tests, which again isn't exactly in order there. But the idea of regression testing is it's a smaller portion of some of the other testing that's happened. Typically, regression testing is around functionality. I normally regression test because something changed. I fixed a bug, I added a new feature, I changed some hardware, I reconfigured the server, something along those lines. Regression testing could retest performance. That could be something that could happen. I want to go look at the performance of the system and double check that the performance still works behind. So we're going to talk about performance testing in a minute. But the most common places I do regression testing is simply going and checking the system of something that already worked. Normally, I don't write special tests for regression unless for some reason my tests are really thick and heavy and I write a smaller, easier to do test up front. Normally what I do is I just simply reuse some existing tests that are out there. I mentioned a moment ago performance testing. Performance really doesn't care about the functionality. I've actually seen it crazy where performance tests is completely ignored the functionality. The performance test turns out great because the system didn't do any of the required functionality. Every test case failed from a functional standpoint, but it was performing really fast. So there's normally at least some care about functionality. But generally speaking, I'm looking at how quickly it ran, or when it ran, how much of the processor did it use, or how much of the memory did it use, or how much data does it store over time in the database, or does it archive it appropriately? Basically non-functional aspects of the system. Then kind of like the final stage of your testing, not exactly, we're going to have one more, but is your user acceptance testing. So it's when the development team says, I think everything's working, and furthermore, I think it's working with acceptable timing and resource use and all the non-functional stuff. Here, you, user of the system or owner of the system or whoever is a stakeholder, whatever you care about the system, does this meet your needs? Now, this could be formally done or informally done. It could be done early in the project or late in the project. The idea is just gaining some sort of check mark that it does what it's supposed to do. If you have technologically illiterate folks, often you want to get them involved early on some prototypes to make sure it meets their needs. If you have technologically illiterate folks, sometimes you want to isolate them from an early system that has some bugs in it because they might get scared and say, oh my gosh, this is a terrible system. I think that's an unfortunate way of handling it because you need to train your consumers, your stakeholders eventually of what the nature of software is. There'll be bugs and then we'll fix them. But you need to basically decide when you're going to bring those folks in because eventually you get to the final stage of testing, which is after you've released your code. Ideally, what we would do is we release the system out there, and then before we let the public get at it, we have one more quick set of tests that we run to make sure what we just released actually does what we think it does. Because every so often, you'll get into the real system, and something will be different on that production server. The permissions will be set up differently, or the table that we thought was structured one way is structured a different way, or something like that. The existing data doesn't conform. And so we want to have that one more check to make sure everything does what it's supposed to do before we head it off to the real world. And that's the place where, you really hope it doesn't work, because if it doesn't, you roll back your software and you go back to the drawing board and push off the release till another day. but often that's a place where you want to go off and make that check. And I'll throw in as a bonus one. We're going to spend a whole last week looking at this a little bit, but we'll talk about reviews, which is the bonus test, which is basically a check all the way along the way to make sure that everything I'm producing is done with some quality before I get to the point of actually being able to test it all. So again, we'll talk about this more the last week, but reviews is kind of like the hidden testing phase that we can go off and talk about.